Hello, today we are talking about networks. What are networks? What can we do with networks? How can we work with networks? And some of the amazing possibilities we have with networks. My name is Eduardo De Bastiani. I'm speaking from Brazil. And today with me will be joining Isaac Howenstine. He was my colleague. We have done some work related with this. And he's a great friend, passionate about his team. So Isaac, how are you?
I'm good, Eduardo. I don't know what to say. Excited to be talking to you under any circumstances. This is a pretty cool thing that you're doing, so I'm happy to be a part of it. Yeah.
Okay, great. First of all, we are going to say what is a network?
Voyage, voyage.
A network can be described. Imagine we have a bunch of nodes, and every node can be like a node could be an object. Nodes could represent people, objects, cities, and we have links between these nodes. And these links are connecting the nodes, and these links could be like friendships. These links could be roads connecting the different cities, and these links can put the information together. And some examples we have on networks. We can have, for example, social networks are a classical example, but not only Facebook, not only the social networks, but the society as an entire group. So all the people together, we can have connections between people. We can have, for example, networks representing the web, the internet, with all the pages and the links between those pages. We can have networks in transportation with all the roads or airports or railroads. We can have networks in the same way in energy systems with the power lines and the energy. And with these networks, we can do some really interesting things. We can, for example, run models. In transportation, we can put a supply on some nodes, and we can put some demands, and we can see how the things flows into the system, integrate it with the economic part to analyze. We can define rules for our models to analyze, for example, which roads we can improve, we can extend, depending on the costs. We can do some analysis. And the interesting thing we can do with networks, we can cross some information and see things that we haven't seen before. So, for example, the DNA, we know that some genes, they have an effect on our body, but we don't know exactly the relationship some genes do with another genes. So with a network, we can analyze this information together and try to understand more information that we can't see like just with looking at every component individually. Do you want to describe networks?
Yeah, I'll try to, because I think you described things pretty well. This kind of interest in a network itself as a concept. An important factor for me is like the idea that everything is related. And so, I mean, just like you can like look at the roots of a tree, and that's like a very obvious, an organism is drawing nutrients from its surrounding environment. You can draw almost non-physical lines between anything, establish like what the nature of the relationship is, and if you can, I guess, probably quantify what the nature of the relationship is. If you can do that, then if you can like establish, like if you can define a link between two things, like this is a banana that I'm going to eat later, a cup. Like obviously there's not like a whole lot that these two items have in common, but if you can come up with like some kind of principle or rule that links two things that most people are not aware of the relationship between, I think that that's like a powerful way of viewing, a powerful way of addressing problems and aiming for goals, like achieving a goal. I just think that almost like any complicated real world problem you have can be visualized on like a flat, in a flat network. And if you add another dimension, the sort of level of processing that a human brain can do is maybe can't handle something like that without a lot of practice. But looking at a network and being able to quantify a relationship between two objects, physical or non-physical, there's always just some kind of hint at the nature of things in the links between them. To me, that's something that I can't really prove at this point. I don't know. But I feel like as science has progressed, human understanding has increased. Like, okay, I'm gonna draw. So I have this paper here. Sometimes the way I visualize like someone's knowledge or a group of people's knowledge is like spikes. So this dot is like complete ignorance. Like when we say learned how to make fire, we got like a little bit of insight into some physical characteristics. But remember, this is still the dot. When we learned about the wheel, we got some idea about some physical idea. When we learned about, how to hunt as a group to kill, that's like another spike out here. As agriculture, this became something. Okay, remember, this is fire. There's like a clear link between these two things where like if you cook your food, what am I trying to say? Like we cook our food for some evolutionary reasons. Once these two things are connected, we start to like fill in some of this knowledge, what was originally a dot, and we get something like this, where like just some fundamental understanding. So we have like a wheel, and we have some understanding of our physical environment. You get something like Newton's law, that's like a new spike. You get something else, and like it's always between. If the real cool shit is happening in this space, to me, figuring out like what the connections are between two things, I think we're like the cutting edge. Anything is happening. You have computers. We have a basic understanding of like physics and biology, some basic neuroscience. As you draw the line between these two things, you get intelligent limbs that interact with your actual nervous system. In the process of building this shit out, and like as we build it out, like this grows, and like we can just keep building it out on like a larger scale progressively. And so like just down to like drawing a line between this guy and this guy and seeing like what is the relationship between these things, and like and so you can come up with like laws that are filling out like our understanding of the universe. This all becomes filled in. And so that I feel like just sort of how maybe our education system works, where like the same thing, you learn basic math, you learn how to add. Think about like what's the opposite of that? Subtract. And then you connect, and then like when you learn what multiplication is, you don't really understand what it is in the beginning, and then you realize it's a type of adding, and all of these things, all these concepts build off each other, and you end up getting like a more complete vision of like whatever you're looking for on like an individual level, on a personal level, like a human scale level. Like the most basic network is one node, another node, and a line between it. Figuring out like what is the fundamental relationship, what's the nature of the relationship that is here. Is it like one way? Is it two ways? I'm getting kind of farther into it, but the connections between things says a lot about the sort of whole framework that you're looking at a situation in. It's just a valuable way of gaining insight into addressing certain problems, in addressing pretty much any problem. So I see it as like a problem-solving tool, and something that's interesting as well. But yeah, I don't know if you have anything to build off of that.
Yes, I really like a lot when you put in that concept of relationship between things and finding insights for solving problems. And actually this is a pretty cool property of networks, because we understand the networks, how they are created, not only like the topology of the networks, but the laws governing their behaviors. We can get some insights from there. So I put some examples here. In society, for example, we can find with the links like how is the power relationship between the people, like how are the clusters created, application with the terrorists cells. We can use networks to understand how these people are connected to try to prevent attacks, to try to discover attacks. We look to the information that we already have, and we try to predict something that will be useful in the future. Companies taking doctors, when they release some new medication, they can analyze which doctors have more influence over the other doctors, so how the things spread over the networks. Actually, how things spread over networks also something really cool to observe. For example, biology, we can analyze like how viruses and disease are spreading over the systems through the biology connections. And also we can analyze, for example, if I take one species, what is the impact over the environment. Economic, we have examples, we can measure the utility for people. Looking at networks, we can measure the utility for groups, we can spread across the network, we can measure impacts we will have on the systems much before we take actions. We are able to understand like the network patterns, we are able to see things, to make better decisions, and to gain much more extra knowledge. About the properties of networks, the first networks models were assumed to be random. We discovered that networks are not random. Every network follows some rules. Networks grows over time, they change, they create new links, they lost links. And it's super interesting to see that most of the networks, they follow some of the same rules. For example, we have hubs.
Can I, before we do this, I have one thing that I want to like bring up. Finding the difference between a node and a link.
Oh yeah, sure, please.
Okay. Like, cause if you have like just a line of links and node, couldn't you just equally like say, okay, this is A, just in terms of the talking about the connections, like this node is linked to this, and this link is linked to this node. I'm curious for you. I have this idea in my mind, but I want to hear from you, like what you think is like the defining difference between a node and a link.
You got me with this question, but a node is something that can create new connections to other nodes, and links are the way they are used to connect between them.
You could say one person is a node, right? Mm-hmm. Okay, just bear with me. Like, I want to get a certain civil engineering job, and I want to be a construction manager, right? Mm-hmm. And like, this is where I am, and this is where I want to get. I'm here with no job, and here's the job. My aunt can get me an interview. Like, you could call her like the link. Couldn't you almost like break down every aspect of potential relationship into many different steps, many different links? My aunt can give me the job, so me. Oh wait, I gotta draw it the other way. Okay, we'll do that. And then I think it's spelled wrong. Whatever. Okay, this is job. This is me, and here's my aunt. Or you could say, aunt. This is the aunt, and this is the job. Okay. Asking this question, it's almost like these things are arbitrary. What you call a node and what you call a link, it's like a theoretical model. It's a theoretical way of like looking at a problem. Mm-hmm. Fair?
Yeah. I think you got a very good point. Depending on your purpose, the problem you are trying to solve, these will be nodes, these will be links, and you can use these different things to solve the different problems you have. Continuing on the properties of the networks, we can have some hubs in the networks. Hubs are like nodes that are more connected to other nodes. In nature is kind of really hard to find hubs because nature, most of the networks follows a bell curve, a normal distribution. But one interesting thing, networks created, we have some power law distributions. A power law could be described as when some of the nodes got most of the links. And this is true, for example, on the internet. A few nodes have most of the links. And even in society, like few people have most of the connections. We have some behavior, like the rich get richer behavior, because we tend to connect to nodes that are richer. But we have something called network fitness, property of a new node entering this network and attract most of the links. Economic, we can see this a lot. For example, we have many big business and a new business enters, and this business is so innovative, starts to reach the nodes, the links, the customers in this case, passes ahead of the other business. There is Einstein law for quantum mechanics, the laws of freezing. Some of the molecules, they start this process, and we can use the same laws to describe how these nodes can influence the other nodes. Another interesting property is the small worlds properties, because even in very, very big networks like the entire humanity, if we count every person as a node, we can have 7 billion nodes, but we can reach each node with 6 degrees of separation. So for example, I can be connected to any person, to the president, like I know a person that knows a person that knows another person that knows the president. And this can be visualized in networks because they created groups inside them. And some people in these groups are connected to other groups. We can find some small world properties. And this is what makes networks stronger. For example, the internet. And we can remove parts of the internet, but it will continue to work because it is really interconnected. This is most about the topology of networks, but yes, we can find these properties in some of them, in most of them. One cool thing is that when we understand how networks behave, we can use networks in most of the areas. For example, in engineering, just like in civil engineering, we can use networks for transportation, to analyze, to use on logistics problems, in water resources. We can use networks in materials science. We can use in economic, like to try to understand how one thing affect other things without like creating laws or doing practical experiences. We can use in biology, for example, to understand how species are related, how viruses spread in the environment. In business, we can make decisions, we can predict things, we can use networks to make better decisions and increase profits. Sociology, we can understand and solve many complex problems, analyzing networks.
From just kind of an economic point of view, if you're going to go for like every last detail on like an engineering project, in the grand scheme of things, like one additional like pipe that links to a house that has small demand is not going to make a huge difference for probably the level of analysis that you're modeling the network of a city for. So the question is like, how high of a level of detail do you want? Part of that issue is like the word that we've been using is skeletonizing a network, where like you have like, say this is the water source here, and then you're going out to all the different demand nodes. Each of these links in ArcMap, it has an attribute table, and it has a bunch of information about it. Like, and one of those things is pipe diameter. And so you can say, I'm looking for all pipes less than 10 inches in diameter. And then, all of a sudden, you're not looking at these anymore. You're only looking at this, and maybe this. That's like one of the more interesting things for me, is like, if you're trying to learn about a network, I think how to model it, and part of that is how to simplify it, and part of that is knowing what the essence of the network is. Mm-hmm. So one simple way of doing it, I feel like most networks should have some of this like hierarchy of diameter, where you start with the thickest and go to the thinnest. Just level of flow, higher level of flow, lower level of flow of whatever. and it could be like information, it could be like human energy, it could be memes, but go by rate of flow, if it's measurable, rate of expected flow. It's kind of a holistic
approach.
In its nature, it's holistic. Yeah. For anyone who is watching this, I speak Chinese. I've studied it for about 8 years. I lived in China for now more than a year in total. Based on sort of that, this is my experience as a foreigner learning Chinese and what this actually has to do with networks. So this is about Chinese, the concept of a character versus a word, and the web of relationships that they share, or the network relationships they share. So first, talking about Chinese to English. I know you speak Portuguese, but bear with me. Chinese to any like Western language, hardly anything can directly translate. So that's just something to sort of bear in mind. It's a fundamentally different language system that does not use an alphabet, and it has different grammar, and so I think that's awesome, but it's kind of just something to keep in mind as I talk about this. So there's two things. This right here, it says 字. 字 means character, and a character is just a single unit of language in Chinese. So this thing itself is a character. It's kind of like a pictogram. It's like a little drawing, but it's just one unit. And most units can fit into a box, a square box. And when you're writing it, it's just a bunch of square boxes next to each other. So is character. Oh shit! Okay, I'm gonna go through these things. All right, so they're individual symbols, and they have a general feeling, aura, or connotation. And I'm just gonna kind of go through a few of these. Like this one, it has a vibe of people. This one has a vibe of book. This one has a vibe of number. This one's kind of abstract. I'm gonna skip this one. Skip this one too. This one has a vibe of hand. This one has a vibe of vehicle. This one has a vibe of beauty, middle, good, country, month, machine. These are characters. This is called a 字. This is a character that represents the concept word. And these are words that are literally used in everyday conversation that refer to tangible objects or concepts that are a little more concrete than an individual character that is generally more abstract. And so a word is usually two characters that are put together, okay? So with that in mind, this is a character that says dian. It means electricity, sort of. It has a vibe of electricity. And this space is kind of to represent all the sort of possible things it could be. It's just a vibe, okay? And then here, this right here is brain, mind or brain or something like that. It's called now. So when you put these two things together, you get dian now. You get a computer. Dian is electricity, now is brain, computer, or electricity, brain, you get computer. Like this exercise that it's trying to do is to sort of, if you look at the shared characters between each line as you go down, so li bian, y bian, y, this is shared here, y tao is coat, shou tao is gloves. You can begin to, because of the relationships that they share, you can build out a sense of what each individual character represents. And part of this is me like studying for a long time, so you get more of a sense actually of this. But shou has a vibe of hand, and this is like another example of just panzi, fei pan, fei ji. So each of these shares the same character. This is pan. This one shares fei. Ji, what is ji? Shou means hand. Ji means like machine. Shou ji. When you put these two together, you get hand machine, which is a cell phone. This applies to every character of the Chinese language. So, just looking at ji, it has connections between shou, like shouji, like I told you earlier, fei, which is feiji, which is airplane, like I told you. This is rz. That means r, it means ear that you listen with. Rz is like headphones. You have this potential web that links each of these characters. And in fact, this character, I would argue, is actually defined in some sense by the relationships that it shares with these other characters. You kind of almost have an aura around this character, which has something to do with relationships, the sum of relationships that it shares. Well, yeah, characters are defined by their relationships in some sense, and characters give insight into how ideas and objects are perceived in Chinese culture. And this is something that people may not be directly aware of, directly conscious of. Because I've asked my Chinese friends, and they're kind of like, shouji is just a cell phone. Like, I'm not thinking of it as a hand machine. You know, it's a shouji, it's a cell phone. I think there is some cultural attitude that you can sort of pull out the nature of these relationships from the Chinese language, because I think you could come up with a map of this and sort of get almost like a Chinese vision of nature and the universe. That's like the essence of what is so cool to me about the Chinese language.
Your presentation is really, 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 really cool. I really loved it. One interesting study it was done, it was like in a map, it was put the food in the same place of the cities, and the mold, this line mold, created a shape to this food and created a network very similar to the network of roads in England. Actually, it was kind of better, the network that mold created, that was created by humans in almost 200 years. In nature, networks are natural also, and this mold can relate it what we created as human and what is created by biological organisms.
Like, you can sort of define, with a couple rules, what your network is, what your sort of framework of analyzing a problem is. And I think it's just incredibly useful for making smart, intelligent decisions and choices, and achieving goals, whether you're an individual or an organization. That's kind of where I'm at right now.
So one thing, networks are really cool and they are important, they are so amazing and they have so much possibilities, is that we have today much more data and much more power to analyze than any other time. And we can, with networks, understand how things are connected. Not only because until now we have been breaking the world into smaller pieces and analyze each piece individually. And with networks we can connect and see the relationship between these things, and we can have an entire new understanding of things, like the whole is greater than the sum of its parts. And so networks can pretty much give us that understand how each thing affects each other, and with networks we can understand and solve complex problems. We can discover new things and we can make better decisions, and hopefully we can push the world forward someday. Thank you very much for watching. A great experience to have. And it was really, really, really nice to speak with you.
Same here.
Thank you very much. Thank you very much.
Thank you too.